Hopefully you've watched through the lecture video that corresponds to section 2. So I'm going to continue to work through some examples out of section 2. So the first couple of problems deal with the definition of a limit, the formal definition of how we get a limit. So this one, they ask us, first of all, to find the limit of this function 5x plus 9 as x approaches 9. So if our function is a polynomial, then it turns out that we can find the limit of that function by direct substitution. If we can directly substitute our value in and it's not undefined or indeterminate, then our limit is our answer. So 5 times 9 is 45, plus 9 is 54. So the limit here is 54. So then they ask us, after we get that limit, to find the largest delta that's greater than 0 such that this is true and this is true. So let's remember what this notation means. So this notation means the distance between a given y value and the limit. So if we look at some graph, some function, and since our function is linear, we'll just, sorry, that's a little thick. Draw a straight line. So we're looking for the limit as x approaches 9, so let's just pretend that 9 is here. So this is the point we're approaching. So if we pick a point a little bit to the right, that point has a particular x value and it has an f of x or a y value. So f of x minus L, that's the difference from the y value to the limit. The limit is the y value that we're approaching as our x gets closer and closer to an x value of 9. So this is saying that as the distance between an arbitrary point and this point, as that distance gets closer and closer to 0.1, or if that distance is less than 0.01, then how does that correspond to a distance in the x direction? This means a distance in the x direction. So C is the x value we're approaching. This x is just the x of an arbitrary point. So if in the y direction we're within 0.01, so if that distance is less than 0.01, then what is this distance less than? So if we're so close here, how close are we here? So that's what that notation means. So how do we figure this out? So f of x we're going to replace with our function, 5x plus 9. L we're going to replace with the limit, which is 54. So the distance between our function, an arbitrary point on our function, and the limit is less than 0.01 whenever the distance between the corresponding x and the 9 that we're approaching is less than delta. So we're looking for delta. So how do we do this? Well, what we need to do is we need to simplify this absolute value. We get 5x 9 minus 54, that's negative 45. We can factor a 5 out. And it turns out with absolute values that if we have a product on the inside, we can take the absolute value of each piece. We can take the absolute value of 5 times the absolute value of x minus 9. Now things that are added and subtracted, that doesn't work with, but with a product and a quotient, we can take the absolute value of each factor. So let's get x minus 9 to the absolute value by itself, so divide both sides by 5. So this simplifies to the absolute value of x minus 9 is less than whatever we get when we do 0.01 divided by 5. So 0.002. Notice this other statement says that the absolute value of x minus 9 is less than delta. So if the left sides match, then the right sides have to match. So that means delta is 0.002. So again, let's go back to what does that mean? So remember, this is the distance in the y direction. So if our distance in the y direction is 0.01, so if we arbitrarily pick a point that is 0.01 from the limit, either above or below it, so that distance is 0.01, or that distance is 0.01. If we are that close in the y direction, that corresponds to this distance in the x direction. So that means from here to here, or from here to here, those are 0.002. For a limit to exist, if we are getting closer in the y direction, we're also getting close in the x direction, and vice versa. If we are getting closer to c in the x direction, that has to correspond to getting closer to a particular value in the y direction. That's what a limit is. So if we can find this value, that shows that our limit exists. Now part B, we're just doing the same thing again. We just have a different epsilon. The difference in the y direction, that's referred to as our epsilon. Think about that in ordered pair, an x comes first, then a y. This is delta, that's epsilon. Delta alphabetically comes before epsilon. So delta refers to the distance in the x direction, epsilon refers to the distance in the y direction. Difference in x's, delta. Difference in y's, epsilon. So let's rework this whole thing. Put in our function, 5x plus 9, minus our limit, which was 54. That's this time going to be less than 0.005. Whenever x minus c, we're still approaching 9, whenever that's less than delta. So this time let's find delta that goes with this epsilon. So we're going to do the same thing. We're going to end up with 5x minus 45. So we're going to be able to factor out of 5 and get 5. Absolute value of x minus 9 is less than 0.005. If we divide both sides by 5, we get the absolute value of x minus 9 is less than 0.001. Our other absolute value was x minus 9 is less than delta. So if we have an epsilon of 0.005, that corresponds to a delta of 0.001. Because if these match, then those match. So there's just a relationship here. If we're this close in the x direction, we're that close in the y direction, and vice versa. And I said that backwards. If we're this close in the x direction, that corresponds to this close in the y direction. On the previous one, we demonstrated a limit by expressing that if we get closer in the y direction, we simultaneously get closer in the x direction. And we did that for very specific distances. More generally speaking, and to do a more formal proof, we want to show that for all values of delta, if we are getting closer to a particular distance in the y direction, we're getting closer to a particular distance in the x direction. You might say, well, when is that not true? Occasionally, if we're getting closer, for example, if we're getting closer to this particular x value, but that is an asymptote, as this distance gets smaller in the x direction, then the distance between that particular value and where we're going isn't approaching any particular distance. It's just going towards infinity. So we need to show that if delta exists, so does epsilon. And that if one gets smaller, the other gets smaller. So how are we going to do that? So first of all, let's speculate what the limit is. For this one, if x is getting close to 4, then our function is getting close to 4 plus 3, or 7. So our limit is 7. So we need to show that as f of x minus L, as that approaches epsilon, then x minus c is approaching delta. So we replace our function with x plus 3, because that's our function. We replace L with 7. And over here, we replace c with the value we're approaching. We're approaching an x value of 4. So on the left, x plus 3 minus 7, that simplifies to x minus 4. Over here, x minus 4 is less than delta. So since these match, then those match. So that means epsilon and delta are equal. So whatever this distance is, this is the same amount. If we're 1/100th of a unit away from 4 in the x direction, then we would also be 1/100th away from the limit in the y direction. If we're 1,000th away from the x, or from 4 in the x direction, we would be 1,000th away from the limit 7 in the y direction. And notice, if this one gets smaller, this one gets smaller. If this one gets bigger, this one gets bigger. So as long as if one gets small, the other one is also getting small, then yes, that limit exists.